my name is Hani and here I will present my report about senior mechanical lab. Actually, in this course, I and my classmates will have in class on the lab. However, because of the pandemic, the mechanism of the class is changes. We divided into the group that will conduct experiment that use the mechanism or phenomenon that occurs in our daily life to be analyzed. There are some mechanisms that often applied in our daily life. Therefore, in this course, it will be only focused on the analysis on implementation of thermodynamics, heat transfer, also the fluid mechanics. And after reading some literature review, I and my group decided to choose the mechanism of stirling engine and water hammer to be used for the experiment, and then to be analyzed. And here's the overview of the content. Here I will explain about introduction, methodology, result analysis, also the conclusion. What is the introduction? The first one is the stirling engine as the representation of the thermodynamics, also the heat transfer. From the picture, we can see that stirling engine using the different temperatures. This is the hot temperature and the cold temperature for the sign of the heat transfer. Therefore, it convert the heat energy to produce the mechanical work, which represent the thermodynamics. And the second one is the water hammer phenomenon that will representing the fluid mechanics mechanism. Basically, the one that will be analyzed is the pressure, also the flow rates during the valve open and close phenomenon. And the third one is the methodology. Here we start with the timeline of the experiment. First is concepting and designing. Basically, we following some instructions from YouTube, also some review on mechanism that relates with the heat transfer, thermodynamics, also the fluid mechanics. Then from this video, we have decide our design, and then we start to purchase our component by using offline and online store. First, we use the offline store to purchase our component. If it's hard to be buy or we cannot find it, we use the online store to purchase our component. And then the third one is the assembly and shipping part. For the assembly, we start assembling from the component that we already purchased. Also, for the shipping, we don't have any shipping cost because of the close area between I and my group, so we can do it together without any shipping cost or additional cost for the shipping. And then the fourth one is the experiment, also the analysis. And this is the purchasing table of our component. We can see the total is around 300,000 rupiah for the first purchasing, and then the second one is the additional purchasing after we decide to make our modification on the design. Then we have the total is around 530,000 rupiah for the total of our purchasing component. And we start with the assembly part. First is the proposed design of the water hammer. We can see that the main component are the valve, the flow meter, and then the Arduino that will be connected to the laptop. And then the third one is the pressure gauge with the connector to the hose, and then the last one is the stopping valve. And then for the water hammer, and this is the real experiment of the water hammer. We can see that we have some modification from the previous one. And here's the fixed component that we use for the water hammer. And this is the first connection is related with the flow meter. We use the flexible hose to be placed in the right and left side of the flow meter to avoid the leak, and then we use the clamp, the pipe, also the seal tape for the pressure gauge is also the connector and the seal tape, and then this is the same things with the previous one. And the last is the stopping valve component. We also use the clamp and then the seal tape for the pipe to reduce the leak possibility of the water hammer. And here's the proposed design of the stirling engine. We can see that there are some components that we not we not usually buy, and because it already exists in our house, such as this one and this one also, but we need to buy the thermometer if we don't have it in our house. As is said before, that we have also some modification during the experiment for the stirling engine, and resulting two models. The first model is being made based on the first proposed design, and then the second one is being made because of the evaluation. Because evaluation after the first models cannot be running well as it expected. And then this is showing the some component that we buy to produce this type of stirling engine. And the third one is the result and also the analysis. This is the video of the water hammer mechanism. You can see this is the first connector, which is between the flexible hole and then the meter that connected to the Arduino and then the laptop. And we can see the flow result. And then here is the connector of the pressure gauge, and the last is for the popping valve. And this is the pressure gauge from the phenomenon. First is the zero, and then this changes is the resulting of the water hammer phenomenon. And here's the summary of the experiment. The left picture is showing the changes of the pressure gauge after the hammer phenomenon. The first one is hitting 20 psi, and then suddenly, in glance, it's showing the decreasing of the pressure, but not directly go to zero. And it also showing the flow meter. The first is static, and then during the hammer is stopped, and then it going increase also after the water hammer is done. Water hammer phenomenon is done, and we can record that the pressure changing is around 7 psi, and then the flow meter changing also around 23 liter per hours. After having some data from the experiment, here is the analysis of the water hammer. We use the Joukowski pressure equation to see the differences of the temperature during the hammer process, and then we can also compare it with the actual from the experiment. First, we need to find the sonic velocity of the pipe, and then using this equation, and then the result is around 1400 meter per second, and then we use the flow from the flow meter, which is around 43 liter per hour. And then for this result, we input it to the Joukowski equation, and we found that the result of the pressure difference is around 6.5, which is close to the actual result from the experiment, around 7 psi. And we can see that this phenomenon can be called as almost accurate with the actual one. Here is the video of the stirling engine. We put the temperature on the hot reservoir and the cold reservoir in the top and the bottom of the stirling engine. And we use two models. This is the first model, and then this is the second model. Then we use this case to be analyzed in the next slide. Using the first model, we measure the initial temperature and also the result of the heating process using the candle. This is the result of the first model. And this is the second model using the first technique. This is the result of the temperature during the heating process. And this is using the second technique of the second model. This is the result of the heating process using the second case and then second model. This is the second model using the third case, and this is the result of the heating process. However, from both of the model, we cannot see this rotating during the heating process. So we rotate it manually using the hand. This is the first model. And then we use the second model using using manually rotating. And we can see also that the rotating mechanism is better and easier compared with the first one. However, still both of them cannot rotate automatically during the heating process. Even there is a different temperature on both of them. So this is the summary of the stirling engine experiment. We can see that we have two models with different condition. The first model, we only have one condition, which is putting the candle directly touching the stirling engine, and with initial temperature around 31.8 degrees Celsius, and this is the final condition after the heating process, which having 48.3 degrees Celsius for the cold reservoir, and then around more than 100 degrees Celsius for the hot reservoir. And for the second model, we have three different conditions. First is having directly touching the candle for the hot reservoir, and the second one is also directly uh, placing the candle downside of the stirling engine with the water applied on the cold reservoir, and then the third one is the placement also for the water in the cold reservoir, and then we have a specific place for the candle, therefore the heat is more stable and we're not directly touching the stirling engine. And we can see also that the implementation of the water in the cold reservoir would affect the initial temperature also, which is having lower temperature comparing with the common or without water in the hot reservoir. And then for the hot reservoir, we have the same amount, almost the same amount of the temperature, and we also have different cold reservoir for the temperature. And here we go to the analysis of the experiment of the steam engine. We can see that the this is still not rotating even we have a big differences temperature because of the heating process. And then the changes that we have made from the first model to the second model is the hole on the that separates the hot and then the cool reservoir of the system. We can see that we made the hole is smaller than the previous one, that we also expect this can rotating, however it's still not rotating. And so we can conclude some reason why it cannot run properly. Basically, it seems to be because of the technical case. First is the hole is not fully spared, the hole and the hole reservoir. Even we have type of the this type of separation, to only make this one is moving because of the difference temperature, but it's still not cannot running the disk. And then the one is the connection is not tight enough, so the mechanism cannot work as it desired. We can see that the connector is not tight enough, but this hot reservoir required this one to be moved, and it is also not compact, so we cannot see the movement of this connector to rotating the disc. And then if this hot temperature will make it rotates and it moves to upward and downwards. However, if it is not tight enough and not compact, so it cannot be done on this system. We can see also from the piston that the transition of the system is run smoothly without any leak on the heat system, also on the setup. So it can support the mechanism of this one, and then the last one. So if we have the right mechanism and then the well prepared setup, we can see that the mechanism can running well. So the differences temperature also can produce work as it expected, as it work on the piston. So this is the conclusion of our experiment. For the conclusion, I put 3 points. They are, and first is the many consideration and criteria that we can call our experiment is successful or run perfectly. The second one is material also design setup play important role on the assembly and then experiment. So if we can choose the right material, also the design setup, then we can expect that our experiment can be running well. And the last is even small accident or even leak needs to be solved and analyzed. So we can see that so it can reflect to the real application of the experiment itself. Uh, for the first point, I and my group some we have done some experiment and we need to modify again the design because still there are some accident or even leak on our experiment. So we need to modify the material, also the setup. Therefore, we can say that the our experiment is running well and there is no even leak or even another accident that can affect our results. So those 3 points are important for us to be considered during the experiment. And then Mr. Jati help us to modify it and also to set up the design and then choosing the material. Thank you, Mr. Jati. And here we go to the feedback of the online session for the lab class. So actually, I feel the differences between having lab session online and offline class. It seems to be difficult because we cannot have the real knowledge that it should be, and we cannot uh, having the available facility that we have on the lab. However, this class we learn something and we learn something also, such as having hands-on experiment for this lab. When we see that we're trying to build our experiment, we're trying to design, we're trying also to analyze what we have made for our experiment. So it is more challenging for us, and then we're trying to be uh, we need to have critical thinking for applying the concept that we have in the class, also problem solving for the problem that we face during the experiment, and also fun, fun and disappointing at the same time because the apa ya the the part that we called that our experiment is failure seems to be more often occurs during this lab session. So yeah, for me, this for the feedback it is challenging, also fun, and then the last is disappointing for having the experiment for my group because we cannot really reach our goals, and then but we learn something for that experiment. And this is our team, me and Siti Zulaikah, and then thank you for your attention. Wassalamualaikum warahmatullahi wabarakatuh.